Hello and welcome to this crash course guide on population perspective. Hopefully it'll be useful for those of you who are in first year revising for your exams, but also hopefully it'll be useful for those in second year who want to take a look back at what they learnt last year and also building on some of the stuff that they learn in second year. So what's going to be looked at in this particular video? Well, we're going to look at the basic concepts of population perspective and the bathtub analogy, as well as types of study design. In the next two videos, in the next two parts, we'll be looking at all these other aspects of population perspective, which I'd consider the building blocks. So, to start with, let's look at some basic concepts of population perspective. So, we have incidence, which essentially is the number of new cases that occur. And therefore, with incidence, we can also think about prevalence, which is the number of existing cases of a disease. If we think about basic definitions, mode is the value that occurs the most. Median is in the middle of all the values. It measures the central tendency of a data set. And mean is our true averages when we add all the values together and divide by however many numbers there are altogether. Remember, no sample is fully representative unless it encompasses everyone in the population, which is very, very unlikely. So you must use a sample, and when using a sample it's a smaller group than the entire population, and with that you've got to think as to whether it's representative. But standard error is something that we can measure, so it's a measure of the deviation of the sample's mean from that of the true population's mean. So essentially, how much does your sample group differ from what the population would show if the whole population was measured, not just your sample group. So some more concepts then. So a correlation coefficient indicates the strength of a pattern, so it indicates the degree of association between one thing and something else. However, a regression coefficient, this evaluates the relationship by describing the pattern. So the underlying words here are indicates and describes, which essentially note your difference between a correlation coefficient and a regression coefficient. So simply saying that height and weight there's quite a strong association between height and weight would be a correlation coefficient. However, being able to describe this and say, well, as height increases, normally weight increases as well, and that's a regression coefficient because it's describing something and saying that in future, if you get someone who's taller, they may also weigh more based on that fact. So some more concepts then. Epidemiology in general refers to the study of how often diseases occur in a group of people and why they occur. A risk factor is anything that increases the likelihood of someone developing a certain injury or disease. And the gold standard is a method or procedure or measurement that is essentially widely accepted as being the best that there is available. One other concept to get your head around, which will be covered later on, is potential life years lost. So this is a measure of the relative impact of a disease on someone's life. Now, three other concepts that I'd recommend becoming familiar with are endemic, epidemic, and pandemic. So an epidemic is the occurrence of cases of an illness or disease in a community or region that is clearly in excess of the normal expectancy. So the amount of cases that you'd normally expect, it's a sudden surge and more of them. An endemic, however, is the constant occurrence of these cases in a certain area or population group. So describing the difference between an epidemic and an endemic, well, an epidemic is a sudden increase above what you'd normally expect, and an endemic is something that's been going on for a while and it's constantly occurring in that specific population or geographical area. And the next concept to consider then is a pandemic, which is an epidemic which crosses international boundaries. So essentially it's saying that it affects a large number of people. It's a sudden increase in the cases above what you'd normally expect, but this time you're looking at crossing international boundaries. It's international, it's happening in more than one place. And the placebo effect. So essentially a placebo is a common word that lay people know, and it's a substance or treatment that's actually got no active therapeutic effect. And a placebo could be given to someone in a particular trial to deceive the recipient into thinking that it's an active treatment, to allow you to compare two groups, one that's actually receiving the treatment and one that isn't. The next things to be aware of are risks. So an absolute risk is the probability of an event occurring. However, a relative risk is the chance of a disease occurring in those exposed to the risk relative to the chance of a disease occurring in those who are not exposed to the risk. An example of this, for example, would be the chance of lung cancer occurring in those that do smoke in comparison to those that don't smoke. So exposing yourself to a risk factor, does that actually increase your chance of a certain disease? The final concept to be aware of is the bathtub analogy, and essentially this is a metaphor describing how incidence and prevalence changes in a population. So the tap and the new water coming into the bath represents the incidence, so the new cases. The prevalence, or the water already in the bath, represents the cases that are already there, the diseases and illnesses that are already recognised as being in that population. And lastly, you can have the mortality, or the loss of cases. Now this could be from either people being cured of their illness and becoming better, or people dying and therefore also leaving the system. So this is essentially a metaphor of showing that actually you have incidence, you have prevalence, and you have mortality, but actually how do those three things impact upon each other? Now we're going to look at types of study design. So I'm not going to spend an awful lot of time on each of these individually, but it is good to know about each one on an individual basis. So you have descriptive studies, cross-sectional, case control, cohort studies, and randomized controlled trials, and also you can have meta-analysis. Now all of these studies, there are more study types than this, but these are the main ones to be aware of. Also, a good bit of terminology to be aware of is that a case report is an individual case, and a case series is a number of same or similar cases. So, descriptive studies then are observational studies, and they describe the patterns of disease in relation to that TPP, so the time, place, and the person. They're often the first step or an initial inquiry into a new topic or disease, and they can be divided into two roles, either studies that emphasize features of a new condition, or studies which describe the health status of communities or populations. The advantages are they're not very expensive, and they're not very time consuming, and it allows a detailed study due to the amount of notes. The disadvantage, however, is that it requires a significant amount of skill to carry out, and that usually the response rates are quite low. Next type of study is a cross-sectional study. So this is also known as a prevalence study. So it gathers information on one or more aspects of an individual in a population at a particular point in time. The aim of it is to take a snapshot, so you're taking a one-off look at a population and collecting data from the prevalent cases. The use of it, so it establishes people's views on health and health services, and it establishes a prevalence of the disease in a population. The advantages of a cross-sectional study is that they are cheap and simple to do. They're ethically safe, and they enable study of many conditions at the same time, because you're just taking up one snapshot. However, they are subject to recall bias, because you're asking people about their experience. We'll cover bias later on. But as well, remember these cross-sectional studies, they must have a high response rate, otherwise you get a biased data set as well. Next you have a case control study, and these are also referred to as retrospective or longitudinal studies. The study in this case is able to measure the exposure prevalence. So what this means is that we're going to take two groups. We're going to look back at the cases, so that's those who've got established disease, and we're going to take a look at the controls as well, so those without the disease. And we need to assess whether a mutual risk factor to both groups is responsible for causing the disease or not. And usually from this type of study you can calculate an odds ratio to compare and express how important that risk factor is. The advantages of a case control study is that they're quick, cheap and easy to perform, and actually you don't need many people a part of it to show an association between the risk factor and the disease. On the other hand, they are subject to selection bias and recall bias. For example, it's difficult to select people with similar controls and a mutual risk factor. And again, it only proves association. It proves association between a risk factor and disease, but it doesn't prove causality. Next type of study is a cohort study. So this is also known as a follow-up or prospective study. And essentially this type of study starts before the disease begins. And individuals are then followed up to see if they've developed that disease which is under study, or another type of disease. And the level of exposure to risk factors as well of each cohort is established at the beginning of the study, which you can imagine is really important because you want to be able to see if it is actually that risk factor that's causing the disease. The aim is to observe large numbers of people over large periods of time, and essentially you want to compare the incident rates of disease in one group and another group, and essentially the only difference between those two groups should be the exposure levels to the risk factor. We can calculate a relative risk based on this, And the advantages of this kind of study is that it's ethically safe, and the outcomes can be standardized, and it reduces that selection and recall bias that we talked about in the case control study. On the other hand, you do have observer bias. There's no blinding or randomization, and you do get a loss of follow-up because patients migrate or they leave the study because you're following them over a large period of time. It's also costly to perform based on the fact it takes a long time. Randomized controlled trials are another type of study design, and essentially you get two groups which are split in a completely random manner, and that's essentially what randomization means. And essentially by doing this, it eliminates selection and allocation bias. Before this, we take the baseline characteristics of each group to ensure that the people in both groups are similar. Then they're subjected purposely to different intervention, and this usually comes into fact with treatment, so placebos versus actual treatment, also with preventative measures such as vaccination, and then both groups are then monitored to see if their outcomes differ. Users-wise, it eliminates confounding factors, it uses placebos, so it's quite a good study design in the respect that it has no bias or confounding, it enables blinding, and randomization makes statistical analysis robust. However, it is at the mercy of volunteer bias who wants to be in the study, and it's expensive and complicated to do, and there are some ethical issues that arise with randomized controlled trials. So an RCT is blind, but how blind is it? Well, it can be single blind trial, double blind, or triple blind, and this basically assesses who knows that about the treatment the patient's getting. So for example, in a single blind trial, it's only the researcher that knows the details of the treatment, but the patient does not. In a double blind trial, the researcher and patient don't know what the treatment the patient has been given, only the doctor who administers it. In a triple blind trial, nobody knows what the patient has been given. Meta-analysis is another type of study design, and the last one we're going to cover today. So a meta-analysis is a statistical analysis that combines the results of lots of different studies, and it's a quantitative study for that reason. It increases the power of a hypothesis which may have been stated in an individual study, but actually if you take lots of these hypotheses together and put them into one big meta-analysis, it makes it more robust, it makes it more powerful. And essentially the advantages of this, as we've just said, it allows inconsistency or results across studies can be quantified, analysed and corrected, and it does increase the power of the hypothesis testing. On the other hand, however, people do tend to unwittingly mix different types of trials and ignore the differences between them in a bid to create a meta-analysis, and as well it may discourage large definitive trials that people may be considering carrying out. Now a few more notes on studies. So first of all, to look at p-values, they are a statistical significance measure, and essentially statistical significance is the probability that an effect is not due to chance alone. This is a little bit about interpretation of p-values, but altogether it says something about your null hypothesis, and a null hypothesis is the opposite to what you are testing. But essentially, when you're testing a null hypothesis, you can get errors, and these can be type 1 or type 2 errors. So a type 1 error is an optimistic error. You've falsely rejected the null hypothesis. So the null hypothesis is the opposite of what you're testing. So for example, if you're trying to prove that smoking causes lung cancer, your null hypothesis will be that smoking does not cause lung cancer. A type 2 error is a pessimistic error, so it's falsely accepting the null hypothesis. An odds ratio is something that you can calculate in a case control study, and it's the odds of an event occurring in one group compared to another group. So take this example here, which you can work through in your own time, about lung cancer and those who don't, and the impact of smoking on that. And there are two simple questions here that you could be asked to calculate in an exam about odds ratios. Following that, you need to then be able to interpret an odds ratio. So for example, if it's greater than 1, there may be an association. If it's less than 1, there may be protective against the association. And then if the odds ratio is 1, the risk factor makes no difference. The last thing to cover in this video are quantitative and qualitative study designs. So quantitative is an ability to quantify data and generalize results from a sample to the population of interest, and qualitative data allows us to gain an understanding of the underlying reasons and motivations behind something. You can look at different types of studies, samples, so a large sample is usually used for quantitative studies, and a small sample for qualitative studies due to the easiness of interpreting the data, and then data collection and outcome as well there. So that's everything for part 1 of this video. Join us next time when we look at more population perspective concepts such as Maxwell's criteria and Bradford Hill.